Hi everybody. Well, it's today time to talk about some application of ogives, which was the cumulative frequency curves. So we also understood how to draw the less than and more than type of ogive, and now it's time to talk about their application. What is this beautiful application of ogives? Well, corresponding to a frequency distribution, we draw ogives. Corresponding to a frequency distribution, we have learnt the concept of finding median, isn't it? Well, application of ogives is the same. With the help of graphical representation of the very frequency distribution, we can find the median. That means we don't need to follow the traditional conventional approach of the formula to get the median of the frequency distribution. Just if we know how to represent it graphically in the form of ogives, then ogives also give you a very nice designed way to get the median of the same frequency distribution. What is the algorithm? First of all, the application is that we will be able to find the median of the given frequency distribution. How? There are two ways in which you can find median for a given frequency distribution. Here we will be discussing the first method, the first way. The first method is through one ogive. Through one ogive. And method 2 is through two ogives. One ogive here can be the less than ogive or the more than ogive. Any one ogive, that is your choice, you can use to get the median of the given frequency distribution. But in method 2, we will be requiring both the ogives, the less than as well as the more than, to get the median. So here only one is more than enough. That is going to complete our entire story. So what is the algorithm? Step number 1 says draw any one less than or more than cumulative frequency curve or ogive for the given frequency distribution. Step number 2. Once you have completed drawing the ogive, the less than or the more than, any one you will be having it in your paper. After that, what you do when you are given a frequency distribution, you have the frequencies. When you add all the frequencies, what do you obtain? You obtain the value of capital N. So that is what you have to obtain. Calculate capital N, which is sum of all frequencies. Okay? And evaluate capital N by 2. Just like we do in the case of median as well, we find out N and we evaluate N by 2. The moment you have evaluated N by 2, what do you do in your ogive? In your y-axis, you have cumulative frequencies plotted, isn't it? In your y-axis, you plot the cumulative frequencies, right? And in the x-axis, you plot the upper limits or the lower limits of the class intervals, depending upon you are drawing the less than ogive or the more than ogive. But on the y-axis, you always have cumulative frequencies. So what you do, the moment you have evaluated this value of N by 2, what you do, you go to step 3. You locate this point N by 2 on the y-axis and mark that point, okay? Draw a line parallel to x-axis. Draw a line parallel to x-axis passing through N by 2. N by 2 is a point marked on the y-axis. You have to draw a line parallel to x-axis passing through N by 2, cutting the ogive, whichever you have drawn, the less than or the more than, cutting the ogive at point P. What I am trying to say is, Suppose this is somehow your ogive, okay? Say this is the more than ogive. I have drawn the more than ogive. So here you will be having the lower limits written of all the class intervals and corresponding cumulative frequencies will be written over here. What you do, you find out capital N and locate n by 2 on the y-axis. Say somewhere here, for example, is n by 2. Say this point is n by 2. Now you draw a line parallel to x-axis. You know this is x-axis. You draw a line parallel to x-axis passing through n by 2. When you will be drawing it, that line will be cutting the ogive at some point P. I am saying the point at which this line passing through n by 2 parallel to x-axis cuts the ogive, name that point P. What you do next after this step is step number 5. Step 5 says draw PM perpendicular to x-axis and declare x coordinate of point P as the median. What is it trying to say? The moment you have got your point P, you drop a perpendicular from P onto the x-axis and say this point is M. So you have PM perpendicular to x-axis. Because this point M is lying on the x-axis, it will be looking like something comma 0. Right? This something is declared as the median. The x coordinate of point M will be the median. That is the algorithm which through just the drawing of one ogive gives you the median of the respective frequency distribution. So what we have to do, we have to draw the ogive either more than or less than. Second step, compute capital N, evaluate correspondingly n by 2, locate it on the y-axis. Draw a line parallel to x-axis passing through n by 2, cutting the ogive at say some point P. Draw PM perpendicular to x-axis and x coordinate of point M will be declared as the median. Easy enough? Let us try to see how actually practically this works out. Let's see. Here before you, you have been given the age groups and here is the frequency. Here I have 5 to 6 years, 6 to 7 years, 7 to 8 years, 8 to 9 and so on till 16 to 17, and here are the respective frequencies, the number of students falling in this age group. Fine, the number of children falling in the respective age groups are these many. Is it clear? What you are supposed to do, you are being asked over here to draw the less than cumulative frequency polygon and cumulative frequency curve and compute the median for this given frequency distribution. First of all, it's a continuous frequency distribution, not a doubt. 5 to 6, then 6 to 7, then 7 to 8, then 8 to 9 and so on, right? So what basically is the thing? You will be asked to do, over here you are asked to do 3 things. 1, draw the cumulative frequency polygon for the less than type. Next, draw the cumulative frequency curve, that is the ogive for the less than type. Third, compute the median. So with the help of one ogive, I know how to get the median by my algorithm, so I will be performing the exact same steps in here and getting to the median. So what is the strategy to move towards, first of all, the less than ogive? What we do, we take a column of less than and write the upper limits, less than 6, less than 7, less than 8, less than 9, less than 10, less than 11, less than 12, less than 13, less than 14, then you have less than 15, less than 16 and less than 17. So here less than is written with respect to the upper limits, these are your upper limits. And next you write the cumulative frequencies. So less than 6 are how many? Less than 6 are 40, here you will be writing 40 corresponding to 6. Less than 7 is 40 plus 56, which is 96, right? Then you have less than 8, less than 8 is 96 plus 60, which is 146, right? Because 9 plus 1 is 10, 10 plus 5 is 15, so you have 96 plus 60 This is 15. So 156. Is it clear? After that you have less than 9. Less than 9 is 40 plus 56 plus 60 plus 66, which is 156 plus 66. What is 150 plus 50? It is 200 plus 10, 210. 210 plus 6 is 216. 216 plus 4 gives you 220. 222 is what you will be getting. You can check 156 plus 66, 6 plus 6 is 12, 6, 6 again 12, and you have 222. Less than 10 is all of this till 84. So till 66 it is 222 plus 84 gives you what? 4 plus 2 is 6, 8 plus 2 is 10, so you have 306. Then you have less than 11 is 306 plus 96. If I add 306 plus 96, I get 402. So you get 402. Right? Then you have less than 12 is plus 92. 402 plus 92, which is 494. Cool? Less than 13 is 494 plus 80, which is 574. Right. After this you have less than 14 is 574 plus 64. 4 plus 4 gives you 8. 6, 6, 12 plus 1, 13, and you have 638. Right. 4 plus 4 gives you 8. 6 plus 6 is 12 plus 1, 13, and you have 638. Then you have less than 15 is 638 plus 44. What is 638 plus 44? This is 12, this is 8, you have 682. Clear? Then you have less than 16 as 682 plus 20. What is it? Plus 20 will give you what? 702, and plus 8 will give you 710. Is it clear what we do? Number of people number of children whose age is less than 6, it is 40. Whose age is less than 7, well, age less than 6 is there, so obviously it is less than 7, so you have 40 plus 56, that is 96 as the total number of children having their age less than 7. Age less than 8, age less than 6 is also age less than 8, age less than 7 is also age less than 8, so I have 40 plus 56 plus 60, which is 156 as the very number of children whose age is less than 8, and that is what we do when we are obtaining the column of cumulative frequency. So when I am talking about age less than 17, all of these are ages less than 17, isn't it? Age less than 6 is age less than 17, age less than 7 implies age less than 17, age less than 8 implies age less than 17, and so on till age less than 16 also implies age less than 17, and this itself means age less than 17. So to compute the number of children whose age is less than 17, you add all of these. When you add all of these, you are getting age less than 17 is of 710 children. That means when you have added all of this, you are getting 710. That means this total is 710. We say this is capital N because sum of all frequencies is denoted by capital N. Now the moment I have got these two columns of less than and cumulative frequency, I don't need to forget that in this case we add an imaginary class interval, which in this case would be 4 to 5 with frequency 0. So you will have less than 5. Less than 5 is the age of 0 students. So here the cumulative frequency will be 0. And so the points that you need to plot are 5, 0. What are the points? It is 5, 0. 6, 40, 7, 96, 8, 156, 9, 222, 10, 306, 11, 402, 12, 494, 13, 574, 14, 638, 15, 682, 17, or I should write 16, 702, and 17, 710. These are the points which you will have to plot. Let me The first question for 1 mark asks us to write 3 methods to evaluate mean for grouped data. Now this is very easy. The first is the direct method. Obviously, if grouped data is given to you, that means you are given xi's and fi's. The direct method says mean is summation fi xi upon summation fi, I varying from 1 to n. So you can write that the data given to you is x1, x2, x3 up till xn with corresponding frequencies f1, f2, f3 up till fn. Then x bar, that is the mean, is given by summation fi upon summation fi xi upon summation fi, which can also be written as summation fi xi upon capital N, where capital N is sum of all frequencies. The next method is your shortcut or assumed mean method. Which says mean is equal to the assumed mean plus summation fi di, I varying from 1 to n, whole upon summation fi, I varying from 1 to n, where these di's are nothing but deviations of xi's from the assumed mean. Cool? And then there is this third method, which is your what? The step deviation method. The step deviation method involves the usage of h and says that mean is assumed mean plus h multiplied by summation fi ui, I varying from 1 to n, whole upon summation fi, I varying from 1 to n, where ui is actually di upon h and di is again deviations of xi's from the assumed mean. These things are clear to you, you just need to write these 3 points. Let's move on to the next question. It says that express the relationship between the 3 measures of central tendency. So the 3 measures of central tendency have what relationship? The relationship is nothing but mode is equal to 3 times median minus 2 times mean. That's the relationship between the 3 measures of central tendency, the mean, median and mode. Moving to the next, it says that this following table shows the ages of patient admitted in a hospital during a year. Find the mode for this given grouped frequency distribution. If I have to find the mode, what is the algorithm? The algorithm says that you have class intervals, you have the frequencies available with you. So these are class intervals, these are frequencies. These class intervals are continuous. Upper limit of one is lower of the other, upper of one is lower of the other, upper of one is lower of the other. So this is a continuous frequency distribution. These are all the frequencies. What you do, you search out for the highest frequency. The highest frequency is 23, right? Highest frequency out of all is 23 and the corresponding class is 35 to 45. So that class is declared as the modal class. It is 35 to 45, right? Then I know what my mode is. Mode is L plus f minus f1 upon 2f minus f1 minus f2 into h, where L is the lower limit of the modal class, which is 35, f is the frequency of the modal class, which is 23, f1 is the frequency of the class preceding the modal class. Preceding the modal class is 25 to 35, its frequency is 21. F2 is frequency of the class succeeding the modal class. Succeeding the modal class is the class 45 to 55, its frequency is 14. And you have H as the class size of the modal class, which is 35 to 45, you have 10 as the class size. In 35 to 45, 45 is excluded. So 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, that is it, these are 10 values. So class size is 10. And just plug it in here, you get the mode. It is 35 plus 23 minus 21 upon 2 into 23, which is 46, minus f1 minus f2. minus 21 minus 14 into h. So what do you get? 2f minus f1 minus f2 is what you have written. So 2 into 23 gives you 46 minus 21 minus 14, and here it is f minus f1. So this gives you 35 plus 23 minus 21 is 2. Now 46 minus 21, 6 minus 1 is 5, so you get 25. 25 minus 14 gives you, what is it? 25 minus 14 gives you 11 into 10. This gives you 35 plus 20 upon 11. This is 35 plus, what is it? 1.8. 11 into 1 is 11. You're left with 9. Put a point, add a 0, 90. That becomes 11 into 8 is 88. So this comes out to be 36.8. So the mode is 36.8. Next question says that write an application of ogives and describe its algorithm. There is this very beautiful application of ogives. What is it? That we can find the median of a frequency distribution with the help of ogives. Ogives help to find the median of frequency distributions in two ways. So you have a frequency distribution. First is the algorithm 1. Okay. What does it say? Let me just portray that to you through a rough diagram. Suppose this is some ogive, okay, either less than ogive or more than ogive. So say this is less than, for example, say this is less than ogive. So algorithm 1 says, first of all, step 1, draw either less than or more than ogive for the given frequency distribution. Okay, either of the two you have to draw. Second is find capital N, which is sum of all frequencies. Find capital N, which is sum of all frequencies, and compute n by 2. This will be some value. So frequency distribution is given to you. You have so many frequencies. Add all them up. Get capital N. Divide n by 2. Get n by 2. Plot n by 2 on y-axis. So on the y-axis, suppose this point is n by 2. Mark that point. Okay. Next is draw a line parallel to x-axis passing through n by 2, cutting the ogive at P. It says that once you have marked n by 2, draw a line parallel to x-axis passing through n by 2, cutting the ogive at P. After that, once P has been marked, draw PM perpendicular to x-axis and declare x coordinate of M as the median. Yes. So it says that once point P you have marked, drop a perpendicular onto the x-axis. This is x-axis. This is y-axis. So drop PM perpendicular to x-axis. Now this point M is going to be something comma 0. On the x-axis you have points like this only, something comma 0. This something is the x coordinate of point M, and this will be declared as the median. Is it understood? So you draw either the less than or the more than ogive. Find out capital N, mark N by 2, draw a line parallel to x-axis cutting the ogive at say some point P. From that point P, you drop a perpendicular PM onto the x-axis and the x-coordinate of point M will be the median. This is one algorithm to get the median from ogives. There is another algorithm which asks us to draw both the ogives. So step number 1, draw both less than and more than ogives. Okay. Let P be their point of intersection. Let P be their point of intersection. So they both will be intersecting somewhere, that point is P. Drop PM perpendicular to x-axis. X coordinate of M is the median. What this is trying to say is, just a rough diagram, this is x-axis, y-axis. So say this is your less than ogive, this is your more than ogive, for example. So this is less than and this is more than ogive. They are meeting each other at a point, say this is point P. From this point P, you drop a perpendicular onto the x-axis, say this point is M, so PM is perpendicular to x-axis. Again, this point M is on the x-axis, so it will be something comma 0. This something is declared as the median, which is the x-coordinate of point M. These are the two ways of finding median with the help of ogives. One is by drawing only one ogive, either less than or more than, and following these steps. Another is drawing both the ogives simultaneously on one axis, finding out that point of intersection, dropping a perpendicular from that point of intersection on the x-axis, and declaring the x-coordinate of the foot of that perpendicular as the median. Next question says that this distribution below shows the number of wickets taken by bowlers in one-day cricket matches. Find the mean number of wickets by choosing a suitable method. What does the mean signify? Let's see. Here, if you try to see, there are class intervals given to you. Fine. So, of course, we will have to first of all get the xi's, which are nothing but the class marks of these class intervals, that is the mid values. Once I have my xi's and fi's are with me because they are large values, and even you can identify here the mid value will be 40, right? Here the mid value will be 40, here the mid value will be 80, which are big numbers. So I cannot go by the direct method. Moreover, we are going to begin with the assumed mean method, and if our di's, we are able to see that they are divisible by a common number h, then we will move on to the step deviation method. So let's first of all get xi's, because fi's we already have. So what is the class mark of this first class interval? It is 40, because 60 plus 20 is 80, 80 upon 2 is 40. Then 100 plus 60 is 160 upon 2 is 80. Next you have this as 250 upon 2 is 125. Then it is 250 plus 150 is what? 400. 400 upon 2 is 200. Then it is 250 plus 350. 200 plus 300 is 500, plus 100 is 600, upon 2 is 300. And here it is 400 plus 300 is 700, plus 100 is 800, upon 2 is 400. So these are your xi's. Corresponding fi's are 7, 5, 16, 12. 7, 5, 16, 12, 2 and 3. Clearly you can see the values are large, so I cannot go by summation fi xi upon summation fi. So what I will be doing? First of all, I will be searching for some assumed mean. I take 200 as my assumed mean. That value of xi, from which if I evaluate deviations of any xi, it comes out to be small numbers. So I evaluate di as xi minus a, that is xi minus 200. 40 minus 200, that is 200 minus 40, which gives you 160 with a minus sign. 80 minus 200 gives you minus 120. 200 minus 125 gives you 75, but here it is 125 minus 200, so it is minus 75. Then you have 200 minus 200, which is 0. 300 minus 200 is 100, and 400 minus 200